Hi, my name is Mr. D, and today I want to take a look at finding derivatives using the chain rule. So we have if y equals tangent u, u equals w minus 1 over w, and w equals the natural log of x, what is the value of dy dx at x equals e? So for this example here, a lot of students will find this challenging because you need to use the chain rule more than once. So to kind of stay organized here, you're just going to go piece by piece. We want to find dy dx. So notice if y is equal to tangent u, then dy dx is equal to the derivative with respect to x of tangent u. But the problem with this expression here is that the variables don't match. We can't take the derivative with respect to x of tangent u because the variables are different. So what we're going to do instead is we're going to take the derivative with respect to u of tangent u. But what we need to do right after is multiply by du dx. Remember, the concept here is that the du over du would cancel and it would bring you right back to d dx. So this is a valid move. So for the next line we would have dy dx equals, and the derivative with respect to u of tangent u is equal to secant squared u, and now we have the times du dx. So this is one line here that's definitely going to be important. We're going to need this one here. But now the question is, we can't just plug in. Now we have to find out what is du dx. So to find du dx, now we're going to move over to the second function here, that u equals w minus 1 over w. So if we start off with this idea here, now we're looking at du dx equals, and now remember, once again, we can't take the derivative with respect to x when our function is in terms of w, so we're going to do ddw of w minus 1 over w. But now we need to multiply by dw dx, here like this. So then du dx is equal to, and the derivative with respect to w of w is just 1, and the derivative with respect to w of 1 over w is negative 1 over w squared. Remember, real quick, 1 over w is w to the negative 1, and if we take the derivative, we're using the power rule, negative 1 times w to the negative 1 minus 1, which gives us the negative 1 over w squared like this. But when we look at this, notice we're going to have two negative signs. So we could change those two negatives to a positive. So this will be 1 plus 1 over w squared, and we have our dw dx. So then the last piece of information we need to find before we could kind of solve this out is what is dw dx. So we'll kind of box this off here because this is going to be important as well. So for the next part, now we want to find dw dx. Well, if you think about it, if w equals natural log of x, now we could just apply the derivative directly. dw dx is equal to ddx of natural log x. So then dw dx equals 1 over x, here like this. So this is the last piece of information that we need, but now we could connect all of this together. So for the next part of this problem, we could go ahead and write all this out. We're going to have dy dx equals, and we have secant squared u times du dx, but du dx is equal to 1 plus 1 over w squared times dw dx, but dw dx is equal to 1 over x. So this is the part of the problem here where the chain rule is being applied more than once. We have to replace du dx with this expression here, 1 plus 1 over w squared times dw dx, which is equal to 1 over x. But now notice we have a variable u, a variable w, and a variable x. So we need to kind of substitute in to make sure everything is in terms of x. That way we can replace x with e. So then for the next line, we're going to have dy dx equals, and we're going to have secant squared of u, but u is equal to w minus 1 over w. And now this whole expression here is being multiplied by 1 plus 1 over, and instead of w we're going to have natural log of x that quantity being squared, times 1 over x. Okay, so then for the next line, notice we still have a variable x and a variable w, so we're going to make a substitution for w again. W is equal to the natural log of x. So for the next line over here, we're going to have dy dx equals, and we have secant squared of natural log x minus 1 over, and we're replacing w again with natural log x, and we're multiplying by 1 plus 1 over natural log of x squared times 1 over x. But now this is the part where we care what happens when x is equal to e. So for the next line, we want to know what happens when x equals e. We're going to have dy dx equals, and now we're going to go term by term. We're going to have secant squared. The natural log of e is equal to 1. Just remember, this is like one of those identities here. E to the first power equals e. So we have the natural log of e is equal to 1 minus 1 over the natural log of e is still equal to 1. And now we have 1 plus 1 over the natural log of e is 1, and 1 squared is 1. And then we have 1 over, and x is equal to e, here like this. So then for the next line, we could kind of simplify all of this. We have dy dx equals, remember this is at x equals e, here like this. We have secant squared, and if you do 1 minus 1 here like this, see this is going to be 1 minus 1 inside parentheses. This is going to tell us we need to find secant squared at 0. But secant squared of 0 is equal to 1. And now for the next line we have 1 plus 1 over 1, which is equal to 2. And then we have times 1 over e, here like this. So then our final answer at x equals 2, at x equals e, we're going to have dy dx equals, we have 1 times 2 times 1 over e is 2 over e, here like this. Okay, so we could go over to our answer key, and we're going to go with choice D. dy dx at x equals e is equal to 2 over e. Okay, well this is going to conclude this video on using the chain rule to find derivatives. Thank you all for watching, and I hope that this was helpful.